quick bit of actual electrical content, and by quick I mean give yourself 45 minutes, yeah, with a toilet break.
Just when you think that this channel couldn't get any more boring.
I'm putting together a PLC test rig. This is the first video I've done on it, in fact. They won't be in order. If this is on YouTube, it'll be in a different order. But I'm putting together a PLC test rig because loads of people ask me that question. How do I do what you do? They ask me that because they want to earn more money. And my answer to you is, why don't you do something I don't do? So although I'm a controls engineer, I don't do code, I don't do PLC programming, I don't do PLCs very much. Fault find them, fix them, fit them, change them out, do all the hardware shit, but I don't do the coding because the last code now is on PLC 5, which anyone will tell you is now an obsolete PLC. It was going obsolete when I was working on it in the 2005, but I cut my teeth and ironbody there, never really got into Siemens, can't be arsed with it, not very good at maths, so I knew that I'd never ever get to the high level stuff. However, I appreciate that it's probably a bit easier now, and it's certainly, as this series is going to show, a lot cheaper to get into because of the Chinese. Is that racist?
Are you thick or something?
Anyhow, I'm making this PLC test rig, and the budget is £250. That's for everything, apart from the hardware, like not all the PLC stuff. I mean, like screws, bits of wood, paint, whatever. Yeah, you can tar it up how you want, but one of the first things I've come across, or was asking about, is shaft encoders. Not had many dealings with them. So I asked in the ESK, it's the best place for electricians on the internet. And anyway, I had a dabble in the ESK, and I went on AliExpress, right? AliExpress doesn't rob you. It's pretty decent. All the things I've ordered have turned up on my credit card, has yet to be robbed. So, I bought a shaft encoder. Let me tell you what I know about shaft encoders, but first. So anyway, my encoder arrived and I was like, I don't know fuck all about encoders. I ain't got a fucking clue, mate. Genuinely, until yesterday I didn't know fuck all about them. I could basically work out, because these often wire into a PLC, you'll have some sort of SCADA in the PLC that tells you its location, where it is, because that's what it does, works out where it is. And often you can go to that code and you can see it's not moving. You're like, fucking shaft encoder's probably fucked, and you swap it out and it then works, and then you home it, tell it where it belongs at the beginning, and that is it. And I realised at that point that is literally my total exposure to shaft encoders, so I was going to need a bit of help from a couple of dodgy looking motherfuckers down the dock. So yeah, first dodgy looking motherfucker, Logical Controls, criminally underfollowed account. If you like what I do, go and follow him. Apparently he goes on TikTok a little bit more. You know what I mean? I'm not saying what I'm going to say, you know what I mean? But people don't hang around TikTok too much. So he hangs around on TikTok too much a bit on there. So Logical Controls on here. Think about some videos there. Follow him. Criminal Underfollowed. Got a really good video on shaft encoders. Suggest you go and watch it. Otherwise, you're a fucking penis. Number 2, alleged approved. Again, criminally underfollowed account. Yeah, probably one of the only, got some of the most excellent videos, apart from my own. But by excellent, I mean, he doesn't produce a piece of shit every week. He's like a goose. He does a golden egg every now and again. Got another video on shaft encoders. The one he's got, although I think he's stolen the graphics, is fucking excellent when it describes absolute encoders and the other encoders, which is the one I've got, the ones that count upwards, basically. I'll briefly go into it, but his graphics are better than mine. Go and look at his. He's on TikTok as well, because they're fucking not. So yeah, go watch those videos. However, as well as watching those videos, unless you're absolutely poor like you're on the breadline, these are dirt cheap. I think these were £6 off AliExpress. Like, there's different types as well, so just be careful. I mean, don't get me wrong. You're not going to fucking put it on a top. You're not going to put it on a tunnel boring machine or a robot that's doing surgery on people's ball bags. But for £6 to fuck around with, if you don't put too much volts in this, you're not going to blow it up. So all I did was set the bench power supply to 35 milliamp, which is low, set it to 5 volts, and off I fucking trotted. But they're about £5. Let me look at the price now for you. Hang on. £7. Yeah, all right. You can't afford to buy 20 of them, but just don't blow it up. Put 5 volts in it. It's going to be all right. That's why I'm going to try and blow mine up for you. So in this video, I'm going to try not to blow mine up, but I'm going to show you some things you can do with it. Yeah. Bench power supply is a great little thing you'll buy. So on this PLC rig, I'm going to assume you own a bench power supply. It's going to cost you about £40. There's different ones, as you can see from that drawing. They come in increments, these do. So there's a 100 increment, a 200, a 360, a 500 720. Now, the increment is how many dicks it makes as it goes round. So a 360 is great because you get one dink per degree. Did I say dick earlier? One dick per degree. I went for the 720, which means you get 2 dicks per degree, which means you get half a degree of accuracy, which is probably great for a player on a PLC, but it's a bit shit on the bench because there's not a lot of turn in it. So from here, all the way around back to here, mine makes 720 dinks, which I'm going to show you in a minute, yeah? Obviously, if you're playing with it and you want to do a demonstration one, I sort of wish now I bought a 100 one, because I'd probably be able to dead lightly turn it. You'll see that problem in a minute. Obviously, get away if I play with it a little bit, but we'll see. But yeah, so anyway, there's the dinks. It also comes with a fully Chinese instruction, but I did manage to successfully translate on Google, onto Google Translate.
Can you not read Chinese? Are you thick or something?
I've got this one here. But I'm just going to test it. I want to see it work. But as I said on the ESK controls chat, how do I see it work? This part is on shaft encoders that I'm doing now. And I feel like I don't fully understand shaft encoders myself. Not really. I'm going to learn about myself and I'm going to come on for the rest. So this video is in another video, like this. That don't make any sense unless you watch it on YouTube, yeah? Go to a dead spot anywhere on the wheel without the green reference point on there. So now we know that if we see yellow and we go to red, we're going clockwise. How an encoder works. But as I said on the ESK controls chat, how do I see it work? How do I test it? Right, so taking my Chinglish instructions and my shaft encoder and my cables coming out, I can work out that I've got a screen, which is that big black twisted up. It's racist. That big black twisted up one. Then the brown and the blue are the pos and the neg. So I'm going to stick 5 volts in it. That leaves me with these 3 wires. So anyway, let's stick 5 volts in it down the brown and the neg, see if the smoke comes out. I've got this power supply. These are the greatest ones, right? With the knobs you turn on. Because if I short these cables out, look, you'll see I've got 5 volts. And you'll see the current limiting set to 0.35. And with a set of knobs like this, with the coarse and the fine, it is so easy to get it right. Whereas the black digital one, you'll see in my other videos that I've got down the office, I've blown 2 things up with it because it's digitally set. So my advice is get one with knobs. I have connected my shaft encoder to pos and neg, 5 volts, and I'm using 11 milliamps to run it. So obviously, it's taking current, it must be doing something. However, I'll never see what it's doing because these cables aren't connected to anything. Let me tell you what these cables are for. These cables are the counts, as I'm going to call them. I don't think that's the proper word, but I'm not going to call them. Again, watch the Ledger Proof video, watch the Logical Controls video, and you decide what you call them. The orange one, in my case, is the one pulse every rotation that a lot of shaft encoders have. So every time we turn this shaft, one rotation, that orange one pulses. Then, as far as I'm aware, this is how it works, yeah? There's 720 pulses on the black one and 720 pulses on the white one. But they pulse on a different disc. So one of them's like classed as like the lower one of a disc, one of them's the higher one of a disc. So if it sees one first, I don't fucking know, but anyway, I'm not exactly sure it works yet. I know it's got a leading edge type thing, but anyway, you'll see pulses on those that should be 720 pulses all the way round. Now, what I'm going to do to try and test that is I've got this LED and I've soldered a bit of cable to the positive leg. It's an MPN lock. Oops, focus. It's MPN, so it's switching the neutral. So if I put the positive leg, which is the green cable, to the live, and put this one to one of those, it should pulse every time I turn it once on that orange cable. So I'm going to do that. So I've got a little yellow leaf for that. Let me set this up because it's well fiddly. Funnily enough, I've not done this. I've done it on the scope. I played with the scope, I played with the pulse. So this should pulse. Oh! 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 Yeah, look. There it is. So that pulsed. There, look. So when that flat is facing the LED, it's pulsing. Let me just try that all the way around. Oh, there it is, yeah. So that's the 1 revolution pulse. So basically, you can say known point count. known point count. Oh, it stopped working. Has it stopped working? There it is. Yeah, it pulls there. So every rotation, you get a known point. So if you imagine the clock fingers go past 12 and it says, oh, you're definitely at 12, and it goes round to there, then gets fucked around a bit, it's always got the option to come back to 12, which is like the home point or the point where you can work it out from. So yeah, there you go. That is working. Although it don't flash every time. It does flash every time, but obviously if you do it slow, it doesn't flash. If you fucking... Look, the faster you do it, the better it seems to be. Let me get a drill. Fuck it, I'm going to drill on this bastard. Hang on. I haven't used a drill. Put a bit of tape in for a slit clutch lock, so I won't fuck it up, and I'll just spin this impact drill around. Ready? So what's happening there is, hang on. What's happening there was, when I thought it wasn't working, I was watching it through the camera. And because it's going so fast, if the camera doesn't take it, this camera's got a shutter still, even though it's digital shutter. If that doesn't light on the shutter pass, you don't see it. So when I spin it with that drill, I'm watching it flash rapidly. But I think you're watching it flash every now and again in random. So that's down to digital shutters, I think. So yeah, frames per second, so it's not seeing it. But I assure you, when I put that drill in there, it is flashing off. But that's just a single rotation. So that I've now made a shaft encoder that can basically count each rotation, doesn't know which way it's going, doesn't know it could work out how fast it's going, I suppose, yeah. Doesn't know which way it's going though, but it counts one pulse every rotation. I'll just try some more time, because if I go slow, I'm seeing flash, 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 flash. Yeah, I'm seeing the flash repeatedly, on, off, on, off, on, off. But the camera's not doing it every time. So if I go a bit faster, look, I can't see that flashing, but you can every now and again. Slow down. Oh, that seems to be good. That's good. That's what I'm seeing at all speeds. That I must have caught the frame rate right there. And if when I slow near the lower end, see, you're not seeing the flashing as good as I am there, so it's down to frame rate basically. Now I'm not trying to trip over the lads that have done it already, so what I'm going to show is I'm going to show the pulse counting live. Now I can't do that at AD because so I was literally ragging a bin outside my house. Can't do that with LED because it's too fast for the camera, but I've got something that will do it over here. Yeah, again I've no grip in here, so I'm going to do it one-handed, but there's the encoder look on the shaft thing. And over there, I've got my oscilloscope, which has got a light on it. This is fucking ball bags footage. Hang on. I'm not an oscilloscope genius. I can just about make it do what I want to do. But if you look on this screen now, look, you'll see, here's the voltage, and each one of these is a count. And then there I've got faster. So you see it's going count, 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 like that. And I'll just demonstrate it because it's hard to show and it's better with the sound. So I'll just do a new recording and I'll just show you. You'll be able to hear the drip doing its thing. Just going to dangle it like that, look. You press single on here, which is a single shot, and I'll go slowly at first. And you can see, look, count, 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 slow. They're the super fast ones, they're fast ones. So that's the counting. It seems that's one count per rotation. And these squares here are in 500 milliseconds, so each one of these is half a second. So there it went 1, 2, 3. So in 1 second it counted 3 times. On the second, middle of the second, on the second. There, I'll have to zoom in and count it, but you see here, look, you can see it count 1, 2, 3, 4, about 20 times, and that's how our scope works. So yeah, basically the general gist is the AliExpress encoder working to a level I can use on my test rig? And the answer to that is yes. What I've done is I've connected 2 probes, one to each A and B phase. Got it on here, look. And I can, oops, clear that. Put it in. Right then, if you're still here, I'm editing this video. The actual bit of video I did after this is shit, because I cannot use an oscilloscope properly, or I was having a bad day, I can't fucking remember, yeah. I don't do a lot of high-speed counting, and I don't know how to use an oscilloscope brilliantly. When I put this out on Instagram, Alistair from the ESK Controls chat has very kindly done with the video you're going to watch now. I'll just put it on, because he gets a much better view of what's going off on the scope and explains it well. This might dive back into my video, or this might be the end, but you get to see it really well in this video. I don't know what I'll do next, so I probably should have watched this for it, but you're here, like, you've probably been here for, like, I don't know, 6 working days. Enjoy.
Greetings. Apologies for the shaky camera. Right, incremental encoder. This one's got differential outputs but are wired single-ended. Your green is channel A and your red is channel B. The yellow one down the bottom is index, which you're not likely to see on camera. As you can see, we turn this really slowly and we just get flashing lights. That doesn't show us shit all. So we're over to the oscilloscope. Now it's referenced in the centre here on the A channel, rising edge. So if we turn the encoder clockwise and try and get it to stop, there we go. We can see that the A, that's the green lines, lead the B lines, that's the pink ones. Try that again, a little bit faster, get it to catch. There you go. And if we turn it the other way, yeah, it makes a swooshy noise as well when it turns that way. You can see that the A leads the B in this case, if I haven't just said the same thing. It's round the centre there if I don't bump this thing. Oh, look at that, he bumps it. Ah, of course. You get lots of pulses anyway, and that's the problem with these things. You get many pulses. This is a 500 pulse per turn encoder. And it's a bit tricky to get the scope to catch a decent amount of them. And that's exactly what you see if trying to turn it really slowly or at a reasonable speed, you will see more lines. It's a challenge. There you go, pulses. So A leads B or B leads A, and that's because the sensors are 90 degrees out of phase on slots that are 180 degrees apart. Or they're not, they're 360 degrees apart because it's a waveform. But if the sensors were 180 degrees apart, they'd pick up the same thing or the exact opposite at the same time, and that's why the pulses are 90 degrees apart, because that's where the optical windows are. So that's how it's able to pick up a change in direction. And if you want more resolution from your encoders, you need to pick up every edge. If you want more resolution, you need to pick up every edge. 1, 2, 3, 4. That gives you 4 times the resolution. Whereas you can pick up the leading edge or the trailing edge of individual pulses for half resolution or 2 times resolution, or you can pick up single pulses, entire widths for single resolution, and ignore the other side other than check it for direction, either clockwise or anti-clockwise. It'll tell you in the data sheet which one's meant to lead first, A or B, depending on the mechanical direction. They're not necessarily going to be the same. Feel free to check and see if there's a standard for that. And as for the flashy lights, I can't really turn it slowly enough. That doesn't much matter, does it? The index appears once every revolution, usually. This one I don't think does though. When the index appears, it's in phase with both A and B, so they will both be high when the index is high. It is in here. There it is. Did you see that? It's like a Rolf Harris sketch. Can you tell what it is yet? Well, it's definitely come up to see you. Right, that's enough waffle from me.
What if you don't have an oscilloscope? You can get some LEDs like I did. So we're saying you've got a bench power supply. You could get some LEDs and play with it, but obviously get one with less counts. Get like a 100 count one. Right, if you've got to buy one of these to play with and you haven't touched it before, don't go on with a 721 like I did. Buy a 361, because you should be able to turn it with your finger 1 degree. Or even better, buy a 100 one, because it'll be obviously divided into 100 bits. Buy a 61, buy a 51, buy something less counts than me if you want to use LEDs. If you want to use a PLC or a scope, the world's your oyster, because the PLC or the scope will work that out for you. However, I do have another bit of test equipment, and I was thinking, can I use my cheap ass tester on it, because it's PMP and MPN in it? So will this work? Can you get one of these £18 tests off AliExpress and test an encoder with it? Well, we're either going to blow it up or find out. Let's do it live. Right, I'm hands-free, so I can't just do it live because I haven't got any fucking tripod or anything because I'm an idiot. And I haven't left any at home. I've took one on the office for various recording jobs I'm doing. So let's put the live and neutrals in, the pos and neg in, see what happens. With the pos and neg in, it's recognising the circuit's closed lock. Let's put the orange one in, which is the 1 count per rotation, and see what these do. Oh! There, look, 1. And again, when they're flat, it's the cable lock. There. Yeah, so it works. Right, the next question is then, can I see one of the other ones that's doing 720 flash a minute? Let's try it. Amazingly, well, not amazing if you're an electronics person, understand this. Yes, it does look. It sounds like guide counter look. I've got to go slowly, but obviously, clearly, it's counting, isn't it? There you go. It does work, so that'll get you that shit. So it's counting one way. I can't count the counts, but I can see it's functioning. Scratching. I know I'm going to break it, but I don't want to. But yeah, does it work as a rudimentary checker? I'd say absolutely. So yeah, that works as a rudimentary checker. And obviously, if you had less counts, I've got 720, it would, yes. Please be aware though, I've worked on machinery where the last machine I had on, it had a 3,600 count. So it was counting, what was that? 0.1 of a degree increments. I've seen 5,000 counts. So if you had a 5,000 count, you'd be very lucky to make this work. Or it'd beep so fast you never hear it. So yeah, does it work? Yes. By the minimum number of counts you feel like you get away with. Probably good for a 360, 1 per degree. I went for 720, 1 per half degree. But I wish I bought 100 now. But when I get the PLC, this works. I'll be able to count on it. This works. I've learned to use my oscilloscope a bit more. And I've played with some LEDs. You've got the other 2 videos, so I'll leave it there. Because I'm going to go, well, I'm going to finish tidying up this office now. Because this works now. Because look at the fucking state of it. It's a shithole. So yeah, welcome to Encoders. I'm just about to leave my garage, someone's asked me already. This is a Rigol DS1054. Chinesium, 4-channel. All the bells and whistles. Did quite a bit of research on it before I got it. Cost about 325 quid at the time. Don't know what they cost now. It's really good. It'll do most people. It's 50 megahertz 4-channel, yeah? Which is plenty for what I want to use it for. So yeah, if you want a starter one, I'd recommend that. You can also get a cheaper 2-channel, but I use 3 on an encoder. That, as people have asked, that's a waveform generator, which I've already used, but it does let me make waveforms to see on the scope and test certain components that you need a waveform generator for. So yeah, can I use both of these to their abilities? I can use about 2% of them. Soldering gear, now you're talking, but I can use about 2% of the things of these. But yeah, they're the ones I've got. Cheapest signal generator on eBay. There's 2-channel and the 4-channel Rigol DS1054.